guys, today we'll discuss about object storage and CDN. So what is object storage and what is CDN? So generally if we see let's say we see about like warehouse analogy. If we see whenever we are doing having some delivery, so first thing is like all the products at the initial stage will be at some uh, big warehouse which is global or which is central to all the people, and then after many days it comes to your our local warehouse, and then from there it comes to us. Our product doesn't directly come from US, right? If we are in India, I'm talking about Indians, okay? So yeah, so it doesn't come from far thing. So here the global storage, whatever is there, global warehouse, that is like object storage is similar to that, and CDN is like local warehouse. So this is like generally a good comparison only. So what object storage is like? Object storage, it stores data as an objects with unique keys. Unique keys. Remember here, unique keys. Unlike the systems with folders, it's a flat structure where each object has a key, data, and metadata. See, each object will have generally key. Key is like wherever it is, that is unique, wherever it is stored, and content is like either it is our JSON or whatever it is, JSON file or CSV file or image or something. And at the same time we'll have metadata of that file. Generally some files will have metadata, so that is what it is. Now if we see it, so yeah, so if we talk about key characteristics of object storage, it like there is no scaling problem here. We can have unlimited scale, we can store petabytes of data, and no capacity planning is needed in object storage. This is one thing. And durability, we see generally whosoever maintains this object storage nodes, they give us 11 nines durability. 11 nines durability means 1 in 100 billion documents might miss. I am telling 100 billion, that is 10 power 11. And if we see the cost for a standard storage, whatever the premium storage is available in that object storage, it is around 0.023 GB per month for standard. Like it is very much cheaper than other databases like Postgres and all other stuff, because they do some internal optimizations to provide us such type of data. So yeah, and if we see, those objects can be accessed by API calls. That is one of the important thing. So and most common object storage services are like, first thing is Amazon S3, AWS, and cloud storage is by Google Cloud, and Azure Blob. Blob means like binary large object, that is by Microsoft. R2 is by Cloudflare. So and generally in there we have many types of storage classes based on. So object storage also has like they also have many types in that. So based on the cost increases or decreases. So the standard and the most premium, we can say, that is 0.023 GB per month, like $0.023 per GB per month. So that is the standard thing, and it is like, for let's say we are accessing files very frequently, we can use that. And let's say we are not we are not uh, requesting the files very frequently. For infrequent access, we can use there is a storage class called infrequent access, and it charges almost half of that standard thing, that is $0.0125 per GB per month. Like it's we can use it for monthly backups and disaster recovery cases. And Glacier, so whatever standard and infrequent access are there, they generally give us the data in instantly, almost instantly. But there is one more storage class called Glacier. It charges very less, like it's around 0.004 GB, like dollar per GB. And but here it takes some minutes to hours to deliver the data. So that is one thing. So as the cost increases, the accessness increases, like as latency decreases. So first thing is standard, second thing is infrequent access. So generally if we want to store some monthly backups or some disaster recovery things, we can store here. Glacier, let's say we need some data be only because of the compliance rules, not just, and we don't use them anywhere. So for that we can use some Glacier storage class. And there is one more thing called deep archive. So if we want to maintain very long term archives, so we use this thing, and its accessness is not very instant. It takes around 12 hours to somewhere around 2 days. So and the cost is like very less. It's around 0.00099 dollar per GB per month. So that is one thing. Now if we talk about CDN, content delivery network, what it does is like at the edge servers, at the edge locations, it caches the content. That is what CDN means, content delivery network. It caches content at edge locations worldwide. Users fetch from the nearest edge server instead of origin. And this is what if you try to fetch from origin, it might take 200 milliseconds to 300 milliseconds. But if there something is there in nearby, it might take 50 milliseconds. So that is one thing. So how it works is like, it works like general cache. First user will hit the edge server. If there is the required content, then it will give us. Let's say if there is not there, so cache hit will miss. So it will again, our request will go to the actual origin server, and from that origin server we will fetch the data, and at the same time it will be also written onto the edge also. So popular CDN providers, if we see, one thing is Cloudflare. They are available around 300 plus locations, and they give free trial. And DDoS protection. DDoS protection is supported by them. So DDoS protection means like generally there will be something called distributed denial of service attacks. So a hacker who has many servers with him, he can send unlimited requests or many huge requests to a single server, and that can crash that server. So Cloudflare CDNs have these things like which actually filter all these requests, and in that way we can reduce the traffic from the DDoS attack. Or one thing is like here, all these DDoS attacks are not going to our main origin server, they are going to CDN provider. So in this way we are protecting from DDoS. And Cloudflare might have some other architecture also in the CDN, like in the CDN also they might have multiple workers. So that is one thing. And one more thing is like AWS CloudFront is there, they have their own native S3 integration and Lambda, all the stuff is there. And some other Fastly provider is there, Akamai provider is there. So there are many other things. And Akamai is like it has a very large network, it is around 4000 plus locations. So if it's a general architecture of object storage and CDN when combined, so let's say user uploaded an image, it goes to the app server and then through the S3 bucket. Now what happens? S3 bucket has, what happened here? S3 bucket has some change. So whenever there is a change in that S3 bucket, there is a Lambda process triggered. What does this? So in the Lambda, whatever code we wrote, let's say we wrote some code to store various sizes of the same image. So it resizes and compresses the same image and stores different types of variants in their S3 storage. So now what happens? Whenever uh, the user tries to gain access the image, first it hits the CDN URL, and let's say it is not there in the edge cache, then again it will hit the origin. From that it will fetch the cache sorry, from that it will fetch the required image and then it will serve. That is one thing. And when do we invalidate it? So where we generally invalidate like cache invalidation methods, we generally use such kind of methods only. So we try to on any update we try to purge the CDN cache for the affected paths. That is one thing. So when to use what? Let's say object storage is like S3 for user uploads, backup and archive data, static website hosting, data lake for analytics, log storage, all these things we can use S3. And when do we use CDN? We use it for static cassettes, video streaming, API response caching, global low latency delivery, DDoS protection. That is one thing. Now let's say we are asked to design image upload and serving pipeline for Instagram. What do we do? We first thing we'll discuss is like upload to app server or directly to S3 with pre-signed URLs. This is one of the important thing. We can directly upload to pre-signed URLs instead of having some made broker like app server. This saves many bandwidth. This saves bandwidth and latency also. The second step is process, like resize, compress and generate thumbnails. Store it in S3 with different storage classes and serve via CDN for global low latency. This is the best method so far. So generally the pipeline has three phases: upload, process and serve. For upload, users upload directly to S3 using pre-signed URLs to avoid burdening app servers. This triggers an app event, S3 notification or SQS to start processing. Processing workers resize images into multiple sizes, thumbnail, medium, full, compress them and generate different formats like WebP for modern browsers and JPEG fallback. So all variants are stored in S3 for serving. CloudFront CDN sits in front of S3 here. So caching images at edge locations globally. Old images can transition to S3 infrequent access. That is one thing. So whatsoever are there in the standard S3 access, we can eventually, let's say after 30 days, we can send them to infrequent access. That is one thing. So in CDN, how can we handle cache invalidation when content is updated? One thing is like version URLs. So whatever URLs we are having to the CDN, what do we do is like in that, let's say we are having some abcd.jpg. Into that we will attach some version tag like v2 or v1. So what happens is like there, so every time we have, so whenever we updated it in the actual database, the image is updated, so we store a new version in that name version tag. So we check for the same version, updated version in the CDN. That actually that version tag will be with the app server and with the client, but not with the cache. So there will be a cache miss, and now cache again will whatever CDN will again be filled from the DB call. So in that way we can do it. Or there is something called CDN purge API. So CDN purge API means, so yeah, that is one thing. The best approach will be like, first thing, when an image is updated, it gets a new file name or URL. So old cached versions in that new file name will have cache version also. So old cache versions becomes irrelevant here. So this is very cache friendly. So let's say if we must update in place, we use something called cache busting query strings. Instead of versioning, we can have something called cache busting query strings where image.jpg we will be having, and we will be having version number. So here we changes on update, version changes on update, so we will change accordingly. For urgent updates, most CDNs provide purge APIs to invalidate specific URLs or wildcards. That is also one thing, like Let's say we updated something on the database, so we will call a purge API from that server to update the CDN. That is one thing. Purge API to invalidate specific URLs or wildcards. So, and one more thing is like we can use time to lose short TTLs. Like it is very simple, like it will be between minutes to hours for frequently changing content, and long TTLs for days to weeks for static assets. The trade-off is between freshness and cache hit rate. That is one thing. And how do we optimize the video streaming services? Like storage tiering based on access patterns, that is one thing. Lifecycle policies for automatic transitions. Delete unpopular content or move to archive, this is also one thing. Consider multi resolution transcoding trade-offs, that is also one thing. Transcoding is done at other, not done at edge, it is done at object storage side. So videos have distinct access patterns, hot for the first week, then rapidly declining. So we would use life cycle policies, like videos start in S3 standard for the first 30 days frequent access, transition to S3 in frequent access to 30 days. So it is 60% cheaper. Then Glacier Deep Archive at 90 days, that is 95% cheaper for long term retention. For transcoding, I would balance storage versus compute. Storing 5 quality levels per video uses 5x storage, that avoids retranscoding. Yeah. For rarely watched videos, we shall keep only one version among those 5 storages, and we would track per video access metrics to make intelligent tiering decisions, which standard up to use. So what is the use of pre-signed URLs is like it is for direct client to storage access. We can bypass the app servers for large file transfers, time limited access for security. We can add, like that thing is also is provided, and authenticated APIs, where we will try to use authenticated APIs which pass through our app server only when we need to use some control logic. Else we can use direct submission to storage itself. So S3 achieves 11 nines of durability. How is it? Because of data replication across multiple availability zones, checksums to detect corruption, automatic healing of corrupted data, redundancy exits what's needed. So S3 achieves 11 nines durability through redundancy and integrity checks. So when you upload an object, S3 automatically replicates it across at least 3 availability zones in the region. Each copy is on separate physical hardware checksums, verify data integrity on every read and write. If corruption is detected, S3 automatically heals from other copies. The math with 3 copies, each with 3 nines and independent failure modes, the probability of losing all 3 simultaneously is astronomically low. So S3 continuously monitors and replaces failing drives before data loss occurs. That is one thing. So what is the primary purpose of a CDN? To cache content at edge locations closer to users. So which S3 storage class is most cost effective? That is, we can tell it as Glacier. Sorry. Is most cost effective for data accessed once a month is like we can use in infrequent access. And what is pre-signed URL used for, like between direct client to upload or download S3 without servers. Version URL caching works. How does it happen? Each update creates a new URL, making old copies really relevant. S3 durability of 11 nines means 1 out of 100 billion per year are missed. Thank you.